Hi, I am JJ. Today we are going to discuss one of the important topic in mathematics, relations. Before we start with relations, you should have a basic idea on what is Cartesian product. If A and B are two sets, 1, 2, 3 and 3, 4, 5, the Cartesian product of these two sets A and B is given by A cross B, which is obtained by 1, 3, 1, 4, 1, 5, 2, 3, 2, 4, 2, 5, 3, 3, 3, 4, 3, 5. Each element we write inside a curve bracket as a point or as an ordered pair. In graph, we use x and y axis. We take a point 2, 3, 4, 5. That way we write it here. Ordered pairs 1, 3, 1, 4, 1, 5, 2, 3, 2, 4, 2, 5, 3, 3, 3, 4, 3, 5. That is called as A cross B. So when we are considering A cross B, the first element should be from A, second element should be from B. A cross B. So if I am writing x, y, x should be from A and y should be from B. All such possible ordered pairs put inside a set is called as Cartesian product. If I consider A as 1, 2, 3, what will be my A cross A? I'm going to take the cross with the same set. So my second set is also 1, 2, 3. First set is also 1, 2, 3. Considering A cross A, so it will be 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. So entire thing put inside a set, that will be your A cross A. So this will be my A cross A Cartesian product of the set A with itself. Now what I'm going to do is consider these elements as x and y. First element is considered as x, second element is considered as y. Now here I am going to write it in a set builder form x, y such that x and y is from A. So all these elements x and y, first elements and second elements are from A. So that much is satisfied, such that x is equal to y or y equal to x. So can you tell me what will be the elements in this A cross A which satisfies x is equal to y? X and y should be equal. So obviously here if you see 1, 1, they are equal. 2, 2, that is equal. And 3, 3, they are equal. So my set which satisfies this condition, y equal to x or x equal to y, is 1, 1, 2, 2, 3, 3 from the set A. Another relation which I consider, again the initial part is x, y, and x and y are from set A. Y equal to x plus 1. Y is 1 more than x. So which are the elements satisfying that? Y is 1 more than x. 1, 2, 2, 3. Yeah. So this 2 will be the elements which is satisfying that condition, y equal to x plus y. Similarly, the one more example, y greater than x. Which are the elements which satisfies the condition? The second element is your y, first element is your x. So the second element should be more than the first element. So the elements which is satisfying those condition in the set A cross A is 1, 2, 1, 3, 2, 3. So basically when we hear relations, we know a human being means we can relate them using the names, maybe father, mother, brother, sister, friend. But when it comes to numbers, how do we relate them? I cannot tell 2 is the father of 3 or 2 is the brother of 4 and all. So we going for a mathematical representation. So the symbols which we use to relate them is equal to, not equal to, less than, greater than, less than or equal to. This we use to relate them. So here if you see, I had used x equal to y as the relation between x and y. That is called as a relation, where x and y are from the given set. Second one, y equal to the condition which is satisfied. That is the relation between the two elements x and y, x coordinate and y coordinate. X and y is related using this condition. Similarly, the third one, y is greater than x. This is basically called as a relation. So my R1, R2, R3, all of them are relations, different relations. I can have many relations. Okay, how many of our subsets are there? That many relations, that many different relations are possible. We know A cross A. How many elements are there here in A cross A? 9 elements are there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the number of possible different relations will be 2 power 9 possible subsets. 2 power 9 different relations are possible from this set A cross A. Hope that is clear to all of you. Now, today we will be discussing 3 types of relations. That is reflexive relation, symmetric relation, and transitive relation. Reflexive relation, a relation such that if an element A is there in set A has 1, then in the relation 1, 1 or A should be present in the relation. Such a relation is called as reflexive. So for every A should be there in R. It can have more elements. It is not only A, it can have more elements, but 1 is there, 1 should be there. 2 is there, 2 should be there. 3 is there, 3 should be there in the relation. Such a relation is called as reflexive relation. So if just for you to understand, I have taken one example. A is set 1, 2, 3, 4 and written 2 relations here, R1 and R2. You see, 1 is there, 1 is there, 2 is there, 2 is there, 3 is there, 3 is there, and 4 is there, 4 is there. So first one is a reflexive relation. Second one, 1, 2, 3 is there, but 4 is missing. Does not belongs to R. So for every element of A, there should be A, A. 4 is there in A, but 4 is missing in R2. That means second one is not a reflexive relation. It can have 1, 4, 3, 4, 3, etc. as extra elements, not an issue. It is not reflexive because 4 is missing. Similarly, R3, 1, 2, 3, 4 is present. So R3 is a relation which is reflexive, and R4, 1 is missing, 2 is there, 3 is missing. So any one reason is enough. 1 is missing. That means it is not reflexive. Hope reflexive relation is clear to you. Next, we have symmetric relation. If AB is there in R, then BA should be there in R. So 1, 2 is there in R, 2, 1 should be there. So another example, 1, 2, 3, R1, R2. So if you see every element, we have to check here in R, not A, R. 1, 2, the reverse of the 2, 1, 2, 1 is there. 1, 2, 2, 1 is there. 1, 3, 3, 1, 3, 1 is there. 2, 1, 1, 2 already there in the beginning. 3, 1, 1, 3 already there. So for every AB, BA should be there in the set or the relation. Then it is a symmetric relation. Similarly, second one, 1, 1. The reverse is 1, 1, which is already there. We don't repeat elements in set. 2, 2, again 2, 2, 2, 3, 3, 2, 3, 2, 2, 3. Every element, the reverse AB, BA is there in the relation R2 also. So that is also a symmetric relation. Similarly, R3, it is going to be symmetric. 1, 1, 2, 2, 3, 3. Reverse it, you'll get the same set. It is present. R4, 1, 2 is there, 2, 1 is there, fine. 2, 1, 1, 2 is there, but 2, 3, 3, 2 is missing. 3, 2 is not there, so it is not symmetric. Similarly, R5, 1, 3 is there, 3, 1 is missing. So the last R4 and R5 are not symmetric relation. R1, R2, R3 are symmetric relation. And the last one, transitive. Transitive, if AB is there in R and BC is there in R. If AB and BC is present in R, then we check for AC. AB, BC, AB, and the other one should start with B only. For example, 1, 2, it should be 2 with some other element, maybe 2, 5. 1, 2, 2, 5 is there in the set R, then we check for 1, 5 also should be there. Okay, these two are equal, then 1, 5 should be there in R. If that is satisfied, then it is called as a transitive relation. Okay, so A, B, B, C, you can see these examples, 2, 2, 2, 1, 2, 1, or 1, 1, 1, 2. This should be equal. Then only that B value should be equal to compare them. A, B, B, C, A, C. All this you can see, 1, 2, 2, 2, 1, 2 should be there. Then it is called as transitive relation. So I have given you 3 examples, R1, R2, R3, which are not transitive. R1, when you consider R1, 1, 1, 1, 2. 1, 2 is already there. 1, 1, 1, 3, again 1, 3 is already there. 1, 2, 2, 3. 1, 2, 2, 3. 1, 3. 1, 3 is again there. 1, 3. 1, 3, nothing starting with 3. So nothing to check. A, B and BC is there, then only I have to check. Otherwise, no need to check anything. It is that element is also transitive. 2, 3. Nothing starting with 3. So that means R1 is a transitive relation. R2. 1, 2, 1, 4. 1, 2, 2, 3. Yeah, you can check this. 1, 2, 2, 3. 1, 3. 1, 3 should be there, which is missing in the set R2. 1, 3 is missing, so I can say it is not transitive. So every element should satisfy. Any one element is not satisfying the condition, transitivity condition, then it is not transitive. Similarly, R3, if you see, let us check whether any elements are there which is not satisfying. 2, 3, 3, 4, 2, 4. It is already there. Okay. 3, 4, nothing starting with 4. 2, 3, nothing else starting with 2, 4, nothing starting with 4, 2, 1. That's all. So it is also transitive. So these are the examples for transitive. So if you observe, I had told 1, 3 in the first case, 1, 3, nothing starting with 3. So I didn't check for that. It is no need to check and find out. If you are able to find, okay, in another way, if I tell, if you are able to find an example which is not satisfying transitivity condition, if you are able to find one A, B, B, C, but not AC, only then we say it is not transitive. Otherwise, it is always transitive. So for A, B, B, C is not there. A, B is there, but there is no B, C. Then no need to check for that. That is neglected. No need to check for AC because there is no B, C only. So A, B, B, C, then only we check for AC. So AB is not there or BC is missing, then I can say that it is transitive. We don't have to check if then condition it is. If first one is satisfying, then only we have to check the second one. So here, if first one only is not satisfying, nothing is there to check. We don't have to check anything. So hope that part is clear. AB, BC, then only AC. Or in other words, you should be able to find one example which is not satisfying the condition with AB, BC is there, but AC is missing. One AC missing you have to show, which will not be available for this kind of problems. For example, if I take 1, 2, 3, 4, this relation, 1, 2, nothing else is starting with 2. So we don't have to check for that element. Next one, 3, 4, nothing starting with 4. So that means this is transitive by this particular condition. Trivially transitive, we don't have to show anything or prove anything. If AB and BC is there, then AC is missing. Only in that case, we tell that it is not transitive. Otherwise, all other case, it is transitive. Hope all the 3 types are clear: reflexive, symmetric, and transitive. And if a relation satisfies all the 3, reflexive, if a relation is reflexive, symmetric, and transitive, then it is called as equivalence relation. A relation which is reflexive, symmetric, and transitive, it is called as equivalence relation. One example I had given, 1, 1, 2, 2, 2, 3. So this is reflexive because 1, 1, 2, 2, 3, 3 is present. Symmetric, 1, 1, the reverse, 1, 1 is already there, 2, 2, reverse is there, 3, 3, reverse is there, 1, 3, 3, 1, it is there. So 3, 1, 1, 3. All the elements AB has BA. Now coming to transitivity condition, 1 1, nothing else, starting 1 3 1 3 is there, 1 3 3 1. Okay, this two, if I take 1 3 3 1 1 1, it's already there. So I'm not able to find out any element which is not satisfying the transitivity condition, that is AB, BC. AC is not there, I'm not able to find. That means it is transitive. So it is satisfying all the three conditions, reflexive, symmetric, and transitive. It is an equivalence relation. Hope the types of relations are also clear. Next video, I will come up with functions. So see you with the next video. Thank you.